Welcome to this training on trenching and excavations, competent person. Subsurface installations. Subsurface encumbrances. All surface encumbrances that are located so as to create a hazard to employees shall be removed or supported as necessary to safeguard employees. The approximate location of subsurface installations such as sewer, telephone, fuel, electric, water lines, or any other subsurface installations that reasonably may be expected to be encountered during excavation work shall be determined by the excavator prior to opening an excavation. Excavation shall not commence until 1. The excavation area has been marked as specified in Government Code Section 4216.2 by the excavator, and 2. The excavator has received a positive response from all known operator owners of subsurface installations within the boundaries of the proposed project. Those responses confirm that the owner-operators have located their installations, and those responses either advise the excavator of those locations or advise the excavator that the owner-operator does not operate a subsurface installation that would be affected by the proposed excavation. When the excavation is proposed within 10 feet of a high-priority subsurface installation, the excavator shall be notified by the facility owner-operator of the existence of a high-priority subsurface installation before the legal excavation start date and time in accordance with Government Code Section 4216.2a, and an on-site meeting involving the excavator and the subsurface installation owner-operator's representative shall be scheduled by the excavator and the owner-operator at a mutually agreed upon time to determine the action or activities required to verify the location of such installations. High-priority subsurface installations are high-pressure natural gas pipelines with normal operating pressures greater than 415 kPa gauge 60 psi-g, petroleum pipelines, pressurized sewage pipelines, conductors or cables that have potential to ground of 60,000 volts or more, or hazardous material pipelines that are potentially hazardous to employees or the public if damaged. All regional notification centers are defined by Government Code 4216J in the area involved, and all known owners of subsurface facilities in the area who are not members of a notification center shall be advised of proposed work at least 2 working days prior to the start of any digging or excavation work. Exception: repair work to subsurface facilities done in response to an emergency as defined in Government Code for Section 4216D. When excavation or boring operations approach the approximate location of subsurface installations, the exact location of the installation shall be determined by safe and acceptable means that will prevent damage to the subsurface installation as provided by Government Code Section 4216.4. While the excavation is open, subsurface installations shall be protected, supported, or removed as necessary to safeguard employees. An excavator discovering or causing damages to a subsurface installation shall immediately notify the facility owner-operator or contact the Regional Notification Center to obtain subsurface installation operator contact information immediately, after which the excavator shall notify the facility operator. All breaks, leaks, nicks, dents, gouges, grooves, or other damages to an installation's lines, conduits, coatings, or cathodic protection shall be reported to the subsurface installation operator. If damage to a high-priority subsurface installation results in the escape of any flammable, toxic, or corrosive gas or liquid, or endangers life, health, or property, the excavator responsible shall immediately notify 911. Or, if 911 is unavailable, the appropriate emergency response personnel having jurisdiction. The facility owner-operator shall also be contacted. Access and egress. A stairway, ladder, ramp, or other safe means of egress shall be located in trench excavations that are 4 feet or more in depth, so as to require no more than 25 feet of lateral travel for employees. Exposure to vehicular travel Employees exposed to public vehicular traffic shall be provided with and shall wear warning vests or other suitable garments marked with or made of reflectorized or high visibility material. Exposure to falling loads. No employee shall be permitted underneath loads handled by lifting or digging equipment. Employees shall be required to stand away from any vehicle being loaded or unloaded to avoid being struck by any spillage or falling materials. Operators may remain in the cab of vehicles being loaded or unloaded when the vehicles are equipped in accordance with Section 1591E to provide adequate protection for the operator during loading and unloading operations. Warning system for mobile equipment. When mobile equipment is operated adjacent to an excavation, or when such equipment is required to approach the edge of an excavation, the operator does not have a clear or direct view of the edge of the excavation, a warning system shall be utilized, such as barricades, hand or mechanical signals, or stop lamps. If possible, the grade should be away from the excavation. Hazardous atmospheres. Where oxygen deficiency, atmospheres containing less than 19.5% oxygen, or a hazardous atmosphere exists or could reasonably be expected to exist, such as in excavations in landfill areas or where excavations in areas where hazardous substances are stored nearby, the atmospheres in the excavation shall be tested before employees enter excavations greater than 4 feet in depth. Adequate precautions shall be taken to prevent employees' exposure to atmospheres containing less than 19.5% oxygen and other hazardous atmospheres. These precautions include providing proper respiratory protection or ventilation. Adequate precautions shall be taken, such as providing ventilation, to prevent employee exposure to an atmosphere containing a concentration of flammable gas in excess of 20% or the lower flammable limit of the gas. Wind controls that are intended to reduce the level of atmospheric contaminants to acceptable levels, testing shall be conducted as often as necessary to ensure that the atmosphere remains safe. Emergency rescue equipment such as breathing apparatus, a safety harness line, or a basket stretcher shall be readily available where hazardous atmospheric conditions exist or may be reasonably be expected to develop during work in an excavation. This equipment shall be attended when in use. Employees entering bell-bottom pier holes or other similar deep and confined footing excavations shall wear a harness with a lifeline securely attached to it. The lifeline shall be separate from any line used to handle materials and shall be individually attended at all times while the employee wearing the lifeline is in the excavation. Whenever internal combustion engine-driven equipment is operated inside a shaft subject to Section 1542 of these orders, a ventilation system shall be provided and operated in accordance with Sections 1530 and 1533B of these orders. Water accumulation. Employees shall not work in excavations in which there is accumulated water, or in excavations in which water is accumulating, unless adequate precautions have been taken to protect employees against hazards posed by water accumulation. The precautions necessary to protect employees adequately vary with each situation, but could include special support or shield system to protect from cave-ins, water removal to control the level of accumulating water, or the use of a safety harness and lifeline. If water is controlled or prevented from accumulating by the use of water removal equipment, the water removal equipment in operation shall be monitored by a competent person to ensure proper operation. If excavation work interrupts the natural drainage of surface water, such as streams, diversion ditches, dikes, or other suitable means shall be used to prevent surface water from entering and to provide adequate drainage of the area adjacent to the excavation. Excavations subject to runoffs from heavy rains will require an inspection by a competent person in compliance with Sections 1541 H1 and H2. Stability of adjacent structures. where the stability of adjoining buildings, walls, or other structures is endangered by excavation operations. Support systems such as shoring, bracing, or underpinning shall be provided to ensure the stability of such structures for the protection of the employees. Excavation below the level of the base or footing of any foundation or retaining wall that could reasonably be expected to pose a hazard to employees shall not be permitted except when a support system such as underpinning is provided to ensure the safety of employees and the stability of the structure, or the excavation is in stable rock, or a registered professional engineer has approved the determination that such excavation work will not pose a hazard to employees. Sidewalks, pavements, and appurtenant structure shall not be undermined unless a support system or other method of protection is provided to protect employees from the possible collapse of such structures. Protection of employees. Adequate protection shall be provided to protect employees from loose rock or soil that could pose a hazard by falling or rolling from the excavation face. Such protection shall consist of scaling to remove loose material, installation of protective barricades at intervals as necessary on the face to stop and contain falling material, or other means that provide equivalent protection. Employees shall be protected from excavation or other materials or equipment that could pose a hazard by falling or rolling into excavations. Protection shall be provided by placing and keeping such materials or equipment at least 2 feet from the edge of excavations, or by the use of retaining devices that are sufficient to prevent materials or equipment from falling or rolling into excavations, or by a combination of both if necessary. Inspection. Daily inspections of excavations, the adjacent areas, and protective systems shall be made by a competent person for evidence of a situation that could result in possible cave-ins, indications of failure of protective systems, hazardous atmospheres, or other hazardous conditions. An inspection shall be conducted by the competent person prior to the start of work and as needed throughout the shift. Inspections shall be made after every rainstorm or other hazard increasing occurrence. These inspections are when employee exposure can be reasonably anticipated. Where the competent person finds evidence of a situation that could result in a possible cave-in, indications of failure of protective systems, hazardous atmospheres, or other hazardous conditions, exposed employees shall be removed from the hazardous area until necessary precautions have been taken to ensure their safety. Fall protection. Where employees or equipment are required or permitted to cross over excavations over 6 feet in depth and wider than 30 inches, walkways or bridges with standard guardrails shall be provided. Adequate barrier physical protection shall be provided at all remotely located excavations. All wells, pits, shafts, etc. shall be barricaded or covered. Upon completion of exploration and other similar operations, temporary wells, pits, shafts, etc. shall be backfilled. Soil identification. Type A means cohesive soils with an unconfined compressive strength of 1.5 ton per square foot or greater. Examples of cohesive soils are clay, silty clay, sandy clay, clay loam, and in some cases, silty clay loam and sandy clay loam. Cemented soils such as caliche and hardpan are also considered type A. However, no soil is type A if the soil is fissured, or the soil is subject to vibration from heavy traffic, pile driving, or similar effects, or the soil has been previously disturbed, or the soil is part of a sloped layered system where the layers dip into the excavation on a slope of 4 horizontal to 1 vertical or greater, or the material is subject to other factors that would require it to be classified as less stable material. Type B soil means cohesive soil with an unconfined compressive strength greater than 0.5 TSF, but less than 1.5 TSF, or granular cohesion soils including angular gravel, similar to crushed rock, silt loam, sandy loam, and in some cases, silty clay loam and sandy clay loam. previously disturbed soils except those which would otherwise be classified as type C soil, soil that meets the unconfined compressive strength or cementation requirements for type A but is fissured or subject to vibration, or dry rock that is not stable, or material that is part of a sloped layered system where the layers dip into the excavation on a slope less steep than 4 horizontal to 1 vertical, but only if the material would otherwise be classified as type B. Class C means cohesive soil with an unconfined compressive strength of 0.5 TSF or less. Granular soils, including gravel, sand, and loamy sand, or submerged soil or soil from which water is freely seeping, or submerged rock that is not stable, or material in a sloped layered system where the layers dip into the excavation on a slope of 4 horizontal to 1 vertical or steeper. Definitions. Cemented soil means a soil in which the particles are held together by a chemical agent, such as calcium carbonate, such that a hand-sized sample cannot be crushed into powder or in individual soil particles by finger pressure. Cohesive soil means clay, fine-grained soil, or soil with a high clay content, which has a cohesive strength. Cohesive soil does not crumble, cannot be excavated with vertical side slopes, and is plastic when moist. Cohesive soil is hard to break up when dry and exhibits significant cohesion when submerged. Cohesive soils include clayey silt, sandy clay, silty clay, and organic clay. Dry soil means soil that does not exhibit visible signs of moisture content. Fissured means a soil material that has a tendency to break along definite planes of fracture with little resistance, or a material that exhibits open cracks such as tension cracks in an exposed surface. Granular soil means gravel, sand, or silt, coarse grain soil, with little or no clay content. Granular soil has no cohesive strength. Some moist granular soils exhibit apparent cohesion. Granular soil cannot be molded when moist and crumbles easily when dry. Layered system. 2 or more distinctly different soil or rock types arranged in layers. Moist soil means a condition in which a soil looks and feels damp. Moist cohesive soil can easily be shaped into a ball and rolled into a small diameter threads before crumbling. Moist granular soil that contains some cohesive material will exhibit signs of cohesion between particles. Plastic means a property of soil which allows the soil to be deformed or molded without cracking or appreciable volume change. Saturated soil means a soil in which the voids are filled with water. Saturation does not require flow. Saturation or near saturation is necessary for the proper use of instruments such as pocket penetrometer or shear vane. Soil classification system means, for the purpose of this subpart, a method of categorizing soil and rock deposits in a hierarchy of stable rock, type A, type B, and type C, in decreasing order of stability. The categories are determined based on the analysis of the properties and performance characteristics of the deposits and the environmental condition of exposure. Stable rock means natural solid mineral matter that can be excavated with vertical sides and remained intact while exposed. Submerged soil means soil which is underwater or is free seeping. Unconfined compressive strength means the load per unit at which a soil will fail in compression. It can be determined by laboratory testing or estimated in the field using a pocket penetrometer, by thumb penetration tests, and other methods. Wet soil means soil that contains significantly more moisture than moist soil, but in such a range of values that cohesive material will slump or begin to flow when vibrated. Granular material that would exhibit cohesive properties when moist will lose those cohesive properties when wet. Basis of classification. The classification of the deposits shall be made based on the results of at least one visual and at least one manual analysis. Such analysis shall be conducted by a competent person using tests described in paragraph D below, or in other recognized methods of soil classification and testing, such as those adopted by the American Society for Testing Materials or the U.S. Department of Agricultural Textural Classification System. Visual test. Observe samples of soil that are excavated and soil in the size of the excavation. Estimate the range of particle size and the relative amounts of the particle size. So, soil that is primarily composed of fine-grained material is cohesive material. Soil composed primarily of coarse-grained sand or gravel is granular material. Observe soil as it is excavated. Soil that remains in clumps when it's excavated is cohesive. Soil that breaks up easily and does not stay in clumps is granular. Observe the side of an open excavation and the surface area adjacent to the excavation. Crack-like openings, such as tension cracks, could indicate fissured material. If chunks of soil fall off a vertical side, the soil could be fissured. Small spalls are evidence of moving ground and are indications of potentially hazardous situations. Observe the area adjacent to the excavation and the excavation itself for evidence of existing utility and other underground structures and to identify previously disturbed soil. Observe the open side of the excavation to identify layered systems. Examine layered systems to identify if the layers slope toward the excavation. Estimate the degree of slope of the layers. Observe the area adjacent to the excavation and the size of the open excavation for evidence of surface water, water seeping from the sides of the excavation, or the location of the level of the water table. Observe the area adjacent to the excavation and the area within the excavation for sources of vibration that may affect the stability of the excavation face. Manual tests. Plasticity. Mold a moist or wet sample of soil into a ball and attempt to roll it into a thread as thin as 1/8 inch in diameter. Cohesive material can be successfully rolled into threads without crumbling. For example, if at least a 2-inch 50mm length of 1/8 inch thread can be held on one end without tearing, the soil is cohesive. Dry strength. If the soil is dry and crumbles on its own with moderate pressure into individual grains or fine powder, it's granular. Any combination of gravel, sand, or silt. If the soil is dry and falls into clumps, which break up into smaller clumps, but the smaller clumps can only be broken up with difficulty, it may be clay and any combination with gravel, sand, or silt. If the dry soil breaks into clumps, which do not break into small clumps, and which can only be broken with difficulty, and there's no visual indication that the soil is fissured, the soil may be considered unfissured. Thumb penetration. The thumb penetration test can be used to estimate the unconfined compressive strength of cohesive soils. This test is based on the thumb penetration test described in the American Society for Testing Materials, ASTM, standard designation D2488, Standard Recommendation Practice for Description of Soils, Visual Manual Procedure. Type A soils with an unconfined compressive strength of 1.5 TSF can be readily indented by the thumb. However, they can be penetrated by the thumb only with great effort. Type C soils with unconfined compressive strength of 0.5 TSF can be easily penetrated several inches by the thumb and can be molded by light finger pressure. This test should be conducted on an undisturbed soil sample, such as a large clump of spoil, as soon as practical after excavation to keep a minimum of the effects of exposure to drying influences. If the excavation is later exposed to wetting influences, rain, flooding, the classification of the soil must be changed accordingly. Other strength tests. Estimates of unconfined compressive strength of soils can be obtained by using a pocket penetrometer or by using a hand-operated shear vane. Drying test. The basic purpose of a drying test is to differentiate between cohesive materials with fissures, unfissured cohesive material, and granular material. The procedure for the drying test involves drying a sample of soil that is approximately 1 inch thick and 6 inches in diameter until it is thoroughly dry. If the sample develops cracks as it dries, significant fissures are indicated. Samples that dry without cracking are to be broken by hand. If considerable force is necessary to break a sample, the soil has significant cohesive material content. The soil can be classified as an unfissured cohesive material, and the unconfined compressive strength should be determined. If a sample breaks easily by hand, it is either a fissured cohesive material or granular material. To distinguish between the two, pulverize the dry clumps of the sample by hand or by stepping on them. If the clumps do not pulverize easily, the material is cohesive with fissures. If they pulverize easily and into very small fragments, the material is granular. Protective devices, sloping and benching. Stable rock will have a maximum allowable slope for excavations less than 20 feet of vertical 90 degrees. Type A will have 3/4 to 1, Type B will have a 1 to 1, and Type C will have a 1.5 to 1. Excavations made in Type B soil, if less than 20 feet, shall have a maximum allowable slope of 1.1. All benched excavations 20 feet or less in depth shall have a maximum allowable slope of 1 to 1 and maximum bench dimensions as follows. For Type C material, all simple slope excavations 20 feet or less in depth shall have a maximum allowable slope of 1.5 to 1. All excavations 20 feet or less in depth that have a vertical sided lower portions shall be shielded or supported to a height of at least 18 inches above the top of the vertical side. All such excavations shall have a maximum allowable slope of 1.5 to 1. Protective devices, aluminum hydraulic shoring. 2-inch cylinders shall be a minimum 2-inch inside diameter with a safe working capacity of not less than 18,000 pounds axial compressive load at maximum extension. Maximum extension is to include full range of cylinder extensions as recommended by product manufacturer. 3-inch cylinders shall be a minimum 3-inch inside diameter with safe work capacity of not less than 30,000 pounds axial compressive load at maximum extension. Maximum extension is to include full range of cylinder extensions as recommended by product manufacturer. All spacing indicated is measured center to center. Vertical shoring rails shall have a minimum section modules of 0.40 inch. When vertical shores are used, there must be a minimum of 3 shores spaced equally horizontally in a group. Plywood shall be a 1.125 inch thick softwood or 0.75 inch thick 14 ply Arctic white birch Finland form. Please note that plywood is not intended as a structural member, but only for prevention of local raveling, sloughing of the trench face between shores. Example 1. A trench dug in Type A soil is 6 feet deep and 3 feet wide. From Table D 1.1, find vertical shores and 2-inch diameter cylinder spaced 8 feet on center, OC, horizontally, and 4 feet on center, OC, vertically. See the figure 1 and 3 for typical installations. Example 2. A trench is dug in Type B soil that does not require sheeting, 13 feet deep and 5 feet wide. From Table D 1.2, find vertical shores for 2-inch diameter cylinders spaced 6.5 feet OC horizontally and 4 feet OC vertically. See figures 1 and 3 for typical installations. A trench is dug in type B soil that does not require sheeting, but does experience some minor leveling of the trench face. The trench is 16 feet deep and 9 feet wide. From table D 1.2, find vertical shores and 2-inch diameter cylinder with special oversleeves as designated by footnote number 2, spaced 5.5 feet OC horizontally and 4 feet OC vertically. Plywood, per footnote G7 to the D1 table, should be used behind the shores. See figures 2 and 3 for typical installations. Example 4. A trench is dug in previously disturbed type B soil with characteristics of a type C soil and will require sheeting. The trench is 18 feet deep and 12 feet wide. 8-foot horizontal spacing between cylinders is desired for working space. From table D 1.3, find horizontal wale with the section modulus of 14 spaced at 4 feet OC vertically and 3-inch diameter cylinder spaced at 9 feet maximum OC horizontally. 3 by 12 timber sheeting is required at close spacing vertically. See figure 4 for typical installation. Example 5. A trench is dug in type C soil, 9 feet deep and 4 feet wide. Horizontal cylinder spacing is in excess of 6 feet is desired for working space. From table D 1.4, find horizontal wale with a section modulus of 7.0 and 2-inch diameter cylinder spaced at 6.5 feet OC horizontally, or find horizontal wale with a 14 section modulus of 3-inch diameter cylinder spaced at 10 feet OC horizontally. Both wales are spaced at 4 feet OC vertically. 3 by 12 timber sheeting is required at close spacing vertically. See figure 4 for typical installation. That's it for the training on trenching and excavations competent person.